Alright, so in this video we're going to talk about scientific notation. So scientific notation is a great way to represent numbers where you can accurately depict how many sig figs they actually have. So first I want to go through a couple problems where we're just writing a number in scientific notation. Then we're going to look at how we would handle it if we were to multiply or divide these numbers that have powers of 10. So the first number we have here is 103500. If you look at this number, it has four significant figures because this 0 counts because it's between two non-zero numbers, and these two do not because while they follow a non-zero number, there's no decimal present. So they're really just placeholders. So if we're writing this in scientific notation, you would put 1.035, because carrying the four sig figs, and then you would represent where the decimal place lies by using powers of 10. So we would say times 10 to the fifth, because you had to go 1, 2, 3, 4, 5. Also, if you multiplied this number by 10 to the fifth in your calculator, you would get that. The second number, we have something that's less than 1, so we're going to have as a negative exponent for the power of 10. So you have 0.004820. These zeros don't count as significant. They're really just placeholders because while there's a decimal present, these zeros do not follow a non-zero number, and this one has nothing going for it at all. This 0, however, counts because it's after non-zero numbers and there's a decimal present. So when you write this, you would put 4.820 times 10 to the negative third. And the reason we write 10 to the negative third is because you would have to move the decimal 3 places in order to get it so that you had one number in front of the decimal. Whenever we write things in scientific notation, there is one number in front of the decimal. So now let's take a look at what happens if we multiply these numbers by each other. How I approach this is I handle the coefficients first, and then look at my powers of 10 second. So I have 1.035 times 4.820. What that gives us when we plug it into the calculator is 4.989. So that's our coefficient. And then we look at our powers of 10. Whenever you're multiplying powers of 10, you essentially add the exponents. So you would get 5 minus 3 gives you 2. So you would report this as 4.989 times 10 to the second. Now if we go and divide them, it's a little bit more complicated. But we still handle it the same way. You look at the coefficients first. So when we divide 1.035 by 4.820, we get 0.2147 when you plug it into the calculator. And then we look at the powers of 10 separately. So whenever you're dividing powers of 10, you subtract the exponent. So 5 minus negative 3 gives you 8. So that gives us times 10 to the 8th. Now our product here is not in scientific notation. So what we have to do is get it to this one number in front of the decimal, as we always would report it. And when we do that, what that does is it makes our number go to 2.147 times 10 to the 7th. So whenever our number goes from small to big, our exponent's going to go from big to small. And if we were going the other way, like if our number was over 10, your number would go from a big number to a small number, and your exponent would go from small to big.